Okay, in this video I'm going to do problem 9 here. And it says rewrite each statement in symbolic form, also determine whether the two statements in each part are equivalent. So I'll start with part A here. Define the set R of things in room M16, and the predicate B of X means that X is red. There's two statements here. One says every chair in the room is painted red. And statement 2 says, for all chairs, if the chair is in the room, then it is painted red. Well, these two really are equivalent. It just says all the chairs in the room are red. And it turns out to do this problem, I'm going to go ahead and define another set. C be the set of all chairs. Okay, and there's no one way to do this, but so statement number 1 I'm going to rewrite. It says every chair in room M16 is painted red. For all X in the room union, intersection, C B of X. This says that all items which are both in the room and chairs are red. Statement 2 says that for all chairs, for all X in the set of chairs, if it's in the room, if X is in that room, then B of X. Okay, so yeah, I apologize if this one wasn't as clear. I meant to define the sets I wanted you to use, but I had to define the set C of all chairs here to kind of make this one doable. In any case, they're equivalent, and there's a number of different ways you can write this sort of statement. Another thing you could say is that for all X's in the room, if X is a chair, then B of X. Okay, so there's a number of ways you could write this, and it's really all the same thing. Okay, saying that all the chairs in that room are red. For part B, D is the predicate that X can fix that door, and the domain is a set of all people P. And statement 1 says nobody can fix that door, and statement 2 says it is not the case that there's somebody who can't fix the door. Statement 1 is clear enough. Statement 2 has these double, triple negatives going on. It's not the case that there is somebody who can't fix it. That means that everybody can fix the door, right? If it is the case that there's somebody who can't fix it, then somebody can't fix it. But if it's not the case, then everybody can fix it. So they're not equivalent. Okay, so for part A, I'll write they are S1 and S2 are equivalent. And for part B, I'll say statement S1 is a statement that says it is not the case that there exists somebody who's a person, and I always make an R instead of a P, such that X can fix the door, D of X. It's not the case that there exists anybody who can fix the door. Nobody can fix that door. And that is equivalent to the statement that for all people, they can't fix the door. Okay. Statement 2 said is not the case. Let's do it literally. Let's take this crazy English with all this double negative. It is not the case that there is somebody. It's not the case that there exists somebody in the set of people such that they can't fix the door. Okay, and we can write that one in an equivalent form that says for all x in the set of people, they can fix the door. Okay, and so S1 and S2 are not equivalent here. Okay, one says that everybody can, and the other one says that everybody can't. Okay, so part C, it says that the predicate f of x is that x is infected, and the domain is all the files on Joe's computer, the set F. Statement 1, let's read them. For all files on Joe's computer, it's not the case that they're not infected. That means all files on Joe's computer are infected, right? Statement 2 says there exists a file which is not infected. Okay, so these two are not equivalent. One says that none of them are infected, and the other one says at least it says there exists one that is not. Okay, yeah, statement 1 says they're all infected, and statement 2 says there's at least one that's not infected. Okay, so they're not equivalent. And statement 1 can be written as for all the files, for all x in the set F, it is not the case that they're not infected. They're not infected. I guess we have a double negative right there, which means that for all x in F, they are infected. Okay? Yeah. When you write it, when you say it's not the case that they're not, that's a double negative straight out, just like that. Okay, statement 2 says that there exists a file. There exists an X in Joe's computer files such that it's not infected. And if you want to rewrite this as an equivalent statement, you can rewrite it as a for all statement. Let's see, it says there's at least one that's not infected. And so we can say it's not the case that they're not all. Let's see. There exists one that's not infected, so it's not the case that they are all infected. And I can just blindly apply the rule where I put the negation, change the for all into an and see if it makes sense in the end. It's not the case that for all of them, P of x. So I negate it out front, I change that there exists to a for all, and I negate it on the inside. And this one now says it's not the case that they're all infected. On the right, it's not the case that they're all infected. On the left, it says there's at least one which isn't infected. Right, those are the same. Okay, so hope that helps, and hope you didn't struggle too much with part A without having a definition for the set of all chairs. Basically, there's a lot of different ways of writing part A out, and I'm kind of wanting to show you that there are a lot of ways to say the same thing here. Okay, hope that helps.